Okay, now the really big news and interesting news. This is interesting news. Okay, so I have been chatting over email with a Japanese researcher, Yukiyasu, or just simply Yuki, Kamatani. It should really be Kamatani et al., this article. And he's given me permission to basically say, to tell the public all the contents of his conversation with me, except for one sentence, which is, it's too bad because this sentence is really a good sentence, but maybe someday later I'll be able to reveal that to the public. And it's really an important. I'm for total free information and so on, but I'm a person of my word. And this is the privacy of email. He has, though, said it's okay to tell the public everything but this one sentence. So I will tell you what this person, Yukiyasu Kamatani, has told me, just as I'm like a person asking for more information about how they can see eyes and so on. And, I asked them a series of questions, and just as quickly as I can. This first question: do you plan next to try to capture and reproduce the sounds a brain hears from outside their body? For example, perhaps you will try to make a loud sound and detect change in the MRI image. And his answer is, we do not have a specific plan for reconstructing sounds, but it's an interesting direction for future research. Question 2. Are you able to use fMRI to see not just the images from the outside universe that enter the eye, but images produced internally by the brain? For example, dreams, or perhaps people can be told to visualize shapes such as squares and triangles in their minds, and the fMRI camera can record the image. Is this one of your research goals? This is the question. His answer, one sentence of his answer, he doesn't want me to tell the public. And it's a tantalizing answer. But he does go on to say, in theory, I believe there is a possibility, as the perception of external objects and internal imagery should share some common neural processes. So he thinks that there definitely is a possibility. He's willing to admit that there is a possibility of seeing internally generated images. That's pretty exciting. This researcher says that he thinks there is a possibility that can happen. Okay, so question 3. And he went beyond that, but I can't tell you how. So similarly, are there plans to try and capture and reproduce the sounds produced internally by a brain? Sounds produced internally, such as a song a person might remember in their mind. Do you think that this will one day be possible, if not already possible? And he writes, we have done a preliminary study in which we tried to classify brain activity patterns by the syllables. For example, po versus go. The subject utters and just imagines. It was possible to some extent, but this is just too classy, measured brain activity. I think it means like to classify. Just a classy, measured brain activity into a few classes according the syllables. His English, it's amazing. My Japanese is non-existent. I don't even speak. I can just say domo arigato and so on, and Ohayo gozaimasu and so on. So according the syllables and not reconstruction of sound. So, it's kind of interesting there. He's saying that, they tried to classify brain activities. And then, of course, the word classify, it's classified government information, is probably what he's referring to, at least in one sense. So, it was possible to some extent to classify the different sounds. This is kind of funny. It made me laugh the first time I read this, because he says, the thing that's obvious to me, like recording the loud sounds into a person's ear, that would be the first thing. It would be so simple. then the internal sounds would be secondary, right? But he kind of says, no, we didn't do that baby step, but we just made that gigantic leap into that's what I could understand. So question 4, are you aware of any other people researching and making advances in this technology? And he writes, Jack Gallant's group, Gallant, at Berkeley is working on a related topic using a different method. Okay, so I looked at Gallant's work, and it's similar, fMRI, and they are doing imaging. And it's interesting that Gallant, in fact, even has an article in Nature, and it predates Kamatani's. It's March 20th, 2008, so it's a few months earlier. And and Gallant basically says, they did a variety of different scenes, like outside scenes and so on, and then they ran these, did the same thing using fMRI to try and have a computer recognize which scene it is out of 10 scenes or something, and the computer matched well. As far as I know, you can look at this, research yourself. I just really quickly glanced at it. And there's no picture of like little neuron letters or anything. There's no pictures of what they showed. There's pictures of like the scenes they showed to people, but there's no picture of the decoded image. All they do is they show a graph which shows like a line of how accurate their guessing was. They don't show the actual picture they used to confirm, the original image. So it's kind of interesting that wouldn't you think? It's kind of like saying, well, we have this orange in our pocket. It's orange colored and it's spherical. Well, we don't have to show it to you, obviously. It's kind of like you have this amazing result, and then you don't show the picture of it. So it seems clear that, and for sure, prove me wrong if somebody else has done it. And there are numerous other sources. There's an entire journal called Neuron Imaging or something like that. There very well may be other pictures out there. I don't know for sure. But as far as I can see, just from a science history perspective, which is important to me, it looks like Kamatani's picture is the first image that I've seen of the decoding of an image of what a person sees. So, so let's move on. So my question 5. Do you see a future mass market for portable MRI cameras that people can use to see each other's eyes and the eyes of their pets? And Kamatani answers, well, I would not deny the possibility. Big advances in MR or other technology would be necessary, though. So, let's see. Question 6. Are you able to see the shapes and letters, such as those that spell the word neuron, in the brain of every species that has a nervous system? Do you plan on testing to see the eyes of different species? And Kamatani answers, in theory it should be possible if you can have an animal laid still in an MR scanner. It also matters how big the animal's brain is, in parentheses. It is easier to analyze a large brain, close parentheses. We do not have a plan for animal experiments, but some people might train monkeys to do a similar fMRI experiment in near future. Question 7. Are people required to take any chemical substance such as barium sulfate to allow the fMRI to see what eyes see, or does this work without having to take any material? And Kamatani's answer is no need for chemical agent, generally fMRI. And that's from Yukiyasu Kamatani, PhD at ATR Computational Neuroscience Laboratories in Japan. So those were my questions, and those were all of Kamatani's answers, with the exception of one sentence, which is a very tantalizing sentence. I'd have to say, that just I would have to put this one is, I'd have to say even really number 2 to the one that he did make public, which is that they were able to determine internal sounds